Hey everyone, welcome back to my channel where we put AI generated code to the test and show you how to avoid the mistakes that even smart models make. If you are new here, I highly recommend checking out the previous videos in this series where we break down bash scripts and Docker files written by AI. It's eye opening, and you will see just how quickly copy paste can go wrong if you are not careful. But today, we are moving up a level. We are asking AI to write Terraform for real AWS infrastructure. Will it get cloud security right, or will it build a disaster? To keep things fair, I used a simple Python script to send this prompt to the local AI model, which I am running using Olama, in this case Mistral. Let's get started. I am going to run this Python script first. Now we are going to provide this prompt. Write a Terraform configuration to create an AWS EC2 instance, comma, open SSH access to the world and output the public IP. So this is the prompt which I am going to give. Here's the catch. I specifically asked for SSH access to the world to see if the AI would blindly follow a risky request. Press enter. The AI gave me the output. I am going to copy exactly this and try to paste it in the Terraform file. And from there, we are going to look step by step. Let's quickly create main.terraform file and try to paste it here. I will try to remove these details. I don't want this. And also, if I scroll above, I don't want this information. All right, let's walk through the Terraform file that the AI generated for spinning up an EC2 instance with all the necessary AWS networking in place. I'll break down each block, what it does, and where you should be careful or improve for production setups. First, we set up the AWS provider and region. Here it's hard coded to US West 2. In a real project, you'd want this as a variable so you can easily deploy to other regions without editing your code everywhere. Next, we are creating a virtual private cloud, your own private network in AWS. The CIDR block here 10.0.0.0/16 gives you lots of IPs for future subnets and resources. Again, for flexibility, this is often a variable in production. To get internet access into your VPC, you attach an internet gateway. This is required for any resources like EC2 that needs public access. Here is a single subnet within our VPC using /24 CIDR for up to 256 IPs. It's set in availability zone US West 2A. In bigger projects, you'd have multiple subnets across different AZs for high availability. The route table ensures all outbound traffic. That's the 0.0.0.0/0 rule is sent through the internet gateway. Then the association links this route table to our subnet. Now, security groups, this is your virtual firewall. This one allows SSH port 22 from anywhere in the world. Warning, this is super risky. Never do this in production. Always restrict SSH to your own IP or your company's VPN. AWS key pair. You need a key pair to SSH into your machine. This code grabs your public key from your local machine. Just make sure the path matches your real key, otherwise, Terraform will fail. Now, for the main event, launching the EC2 instance itself. We use the Amazon AMI for US West 2 and a T2.micro instance. The instance is placed in our VPC and subnet and protected by the security group. Key thing here, the security group is referenced by name, not by ID, which works, but referencing by ID is generally safer and more predictable in Terraform. Remote execution. Provisioner is a nice touch for a demo. It updates the system and writes the public IP into a text file on the server. Just remember, provisioners can fail and aren't considered as a best practice for most Terraform workflows. Finally, we output two useful things, the instance ID and the public IP. This makes it easy to find your server in the AWS console or connect via SSH. We have seen the issues with the AI generated Terraform. Everything is jammed in one single file. Hard coded settings, OpenSSH, and barely any tags. So, what does good look like? I'm going to walk you through step by step how a real DevOps engineer would fix this and turn it into something actually you would use at work. Instead of dumping everything into a single file, we split our code into clear logical files. Let's start by creating files first. Providers.tf followed by variables.tf, output.tf, main.tf. Now we have main.terraform file, output.tf file, provider.tf file, variables.tf file. This isn't just cleaner, it's essential for teamwork, code reviews, and scaling your infrastructure. Let's get rid of all those hard-coded values. In variables.terraform file, we define region, VPC CIDR, subnet CIDR, availability zone, instance type, AMI ID, allow SSH CIDR, key name, public key path. Why? If you need to deploy in a different region or spin up a bigger instance, you just change the variable. No find and replace. No risk of breaking other parts of your config. This makes our code reusable and safe, not just for us, but for any teammate or future project. Let's write provider.tf. This file tells Terraform which cloud provider we are using. In this case, AWS. Notice we are not hard coding the region. Instead, we reference variable.aws region, so you can set the region from a variable or a tf vars file. This makes the project flexible and reusable across AWS regions. I replaced main.terraform with ai.terraform. Let's create a new file, main.tf. Here, now let's dive into main.terraform file. This is where all the AWS resources are declared and linked together. First, we define our VPC using a variable block for the CIDR and add some helpful tags for tracking and billing. Next, we create an internet gateway, attach it to VPC, also tags for clarity. Then we set up a public subnet in our chosen availability zone, again using variables and tags. Our route table directs all outbound traffic to the internet gateway, making this subnet truly public, and we associate subnet to the route table. The security group allows SSH but only from specific IP or network that you control using the. We also add egress rules so instance can reach out to the internet if needed. For secure access, we create a key pair resources that uses your actual SSH public key path from your local machine. Finally, we spin up AWS EC2 instance using variables for AMI, instance type, and key name. The instance is launched in the public subnet with our lockdown security group, and it has some simple user data to start a web server for demo purposes. Every resource is tagged and making it easy to manage, track costs, and clean up after tests. And finally, output.ts gives us the essential right after deployment. The instance ID so you can look up or automate against the EC2 resource, and the public IP making it easy to SSH or view your test web server. Outputs make your Terraform code much easier to use in scripts or when handing off to teammates. So, by splitting our code into these clear logical files and using variables everywhere, we end up with infrastructure as code that's not just working but maintainable, secure, and ready for real world cloud projects. Always remember, structure, reusability, and security comes first, especially when AI is involved. If this was helpful, hit subscribe, like the video, and let me know your questions in the comments. Check the description for a download link to these templates and a Terraform best practices checklist. Thank you for watching. See you in the next video.